Alright, so last time we talked about polynomials. Now we're going to talk about area, surface area, and volume. Um, you can memorize all three of these out if you wish. So you can just memorize these basically as like formula tables. I would suggest you start thinking about this a little differently. So like a triangle being 1/2 the base times the height, like a parallelogram, so a rectangle, for example. I mean, that's two triangles stacked next to each other. So 1/2 of that would be the area of a triangle. So some of these you can derive or just remember easier how the other ones work via understanding other areas, surface areas, and volumes, or intuitively understanding how the volume is being done. In the case of, oh yeah, and then we have our definitions up here. I apologize. So like base, height, width, diagonal, and radius. Diagonal meaning going like corner to corner. Surface area, so we're talking about like a three-dimensional object. We want to know, like if we want to know a box, like we want to know how much cardboard there was. We don't care about how much we can fit in it. We want to know how much cardboard it would take to actually fold the box into existence. Here we're talking about length, height, width, and radius. A lot of times what you're going to see is for objects you're going to get 2 of the bases times the perimeter of the base times the height. And I kind of think of this as you find the area of like a little cylinder, like a coaster that we'd use at a restaurant. And then if you stack those on top of each other, you would eventually come up with a cylinder. So that would be the perimeter times the height. So that's kind of how I think about remembering these instead of memorizing them if you want to do something similar. And then this right here, so this has to do with like finding a slant. So when you think about like a cone, it's not like straight up and down on the side. It's at an angle. So you have to find, what this really is this is the a squared plus b squared equals c squared. So to find c squared, you would square root both sides. So the radius is going to be the base. A times b would be the height. So that's where this is coming from, if you want to understand that more academically. And then this pyramid formula also has a similar type of setup to it as far as finding the slant. I didn't write that all out because it looks extremely confusing, and my hope is that if you understand what's going on with this cone, that this will start to make sense. And actually, I'll jump over here and we can see what I'm talking about. If we had a cone, when we're talking about the slant, so that's the radius and then this is the height. So this would be A, B, and then the hypotenuse C would be the slant. So that would also occur in pyramids as well. So that's what I'm referring to when I'm saying take the square root of r plus h squared, and how that would also apply to pyramids. Next we get to volume, and again you can kind of do a similar thing. So what I was talking about, like the surface area, you'd find like the 2 areas of the coasters, and then you would add the area created by the perimeter times the height. You could also do similar with the discs here. So if I found the area of the disc and then I multiplied by the height, so that would be infinite number of discs stacked on top of each other to a certain height, and that would give you the area overall. So that would apply to cylinders, boxes, anything like that. And that's where this regular prism area comes from too. This cylinder and this rectangular prism volume formula at its core are identical. And that should be it. When we get down to calculus, we'll talk, or I guess we won't talk about it, but we can talk about it here. You can figure out like the mins and maxes of these by taking derivatives. So remember, like critical points and finding out if something's a min or a max in calculus, we can apply that to, you know, area and volume problems to find like the maximum surface area that something could that you could come up with given certain dimensions. Then you'll probably see a problem like that on the Praxis.